At this sheet, these are just some applications of using the trapezoidal rule. The first two are fine. These would be your function values, the heights. Do you know how to work out the h here? Do you know what to do? 1, 2, 3, 4, 5, 6 spaces. What is the height of each if I was to use the trapezoidal rule? No. The whole distance is 60. How many spaces are there? Yeah, there's 6, so each one is 10. The height of each trapezium, if you were to use the trapezoidal rule to approximate this area, the height of each trapezium is 10. Do you know what you would use as the first and the last? Yes, the multiplier pattern times 1, 2, 2, 2, 2, 2, 1. They're the values. No. So girls, all right. So looking at question 2, we're just talking these through. Donald is going to make a feature garden at the front of his country property. He measured the area and made this sketch of the garden. Use all the measurements on the garden and the trapezoidal rule to approximate or to calculate the approximate area of his garden. Okay? So they want you to find the area of this and to approximate it using the trapezoidal rule. So you have to work out what the h is. Do you understand? So we're going to be doing, these are all going to be like trapezia, but you're going to have to work out what h is. You don't have a b and an a. It's not like you're given the x-axis. All you know is that you've got 1, 2, 3, 4, 5, 6 subintervals. So the height of each subinterval is 60 divided by 6, which is 10 meters. Do we get this? And with your area is approximately equal to, isn't it h on 2, which is what on 2? 10 on 2. Now the multiplier pattern. If you want, you can draw up a little table, but you don't need to. Isn't it, won't the first and the last ones just be normal, and then you'll be multiplying each of these ones by, what? 2. So it'll be 20 plus 13 plus 2 times the sum of, are we okay? Of 26 plus 24 plus 18 plus 15 plus 14. So it'll be 5 times, that's 33 plus 2 times whatever that is. I don't know what that's, 50, whatever it is. 79 and 18, 79, 89, 99, 90, 97? I don't know, what are you getting for your answer? Trapezoidal rule is h on 2 with the multiplier pattern of 1, 2, 2, 2, etc. That's the trapezoidal rule approximation for area. H on 2 and the multiplier pattern for the y values, which is the heights, is 1, 2, 2, 2, etc. As many 2's as you need and a 1 on the end. Do you see what I've done? You can, if you want, put those values in. They're 20, 26, 24, 18, 15, 14, and 13. So you're just adding the first and the last, and it's 2 times all the others. All right? Yeah. It's because you have your x and your y value. The x is just the position along the x-axis. The y value is your function. You know how they say you need this many function values? The function is always the y value, the height. All right? The x value just gives you the position of where you are. All right? So what do we get for this?
1,000
meters squared. Now that's part A of the question. Use all the measurements and the trapezoidal rule to find the approximate area. So we found the area. And part B says that Don plans to top dress the garden with 3 centimeters of soil. How many cubic meters of soil will he need? So that is the area of the garden bed. That's the area of his garden, and now he wants to lay soil on top at a certain thickness. They're asking now for the volume. How many cubic meters of soil? They're asking you for volume. Volume is area of the uniform cross-section times the height. Remember? So we know that the area is 1135 meters squared, but the height is, what's your height? 3 centimeters. You can't put centimeters in. What do? That's it. And now that's the volume. So you can often be asked, Simpsons or trapezoidal rule, in application problems like this, where you're going to be doing area and then you'll be finding the volume. Okay, so what do you get? No, not centimeters. 34.05 meters cubed. It's 1135 times 0.03. And girls, you know when I spoke when you integrate, are you finding the area? If I integrate this, remember trapezoidal rule and Simpsons rule, we use them when we can't integrate the function. We don't know, for example, how to integrate log to the base 10 of x. So to approximate the area, you have to use Simpsons or trapezoidal rule. We've been asked to use trapezoidal rule. But when you do the integral of something, it's the area below the curve. Now, if I want to find the shaded area here, if I use trapezoidal rule, where am I finding the area? Up here or down here? I'm finding it down there. So when I use the trapezoidal rule, it gives me the area under there. How am I going to find the shaded area? I'll do rectangle minus area under here. Okay, so this is what they're asking you to do here. You can do this at home, this one, the area of the rectangle, fine. Complete the table for y is log to the base 10 of x. And then you'll use the trapezoidal rule to work out the approximate area here. And then you'll use subtraction to find the size of the shaded area. Okay, now you can do that one at home. I want you to look at this and tell me what's very strange about, oh no, it's fine. You know they're saying find the integral between 7 and 1 of x dy. Have a look what x is. X is g of y dy. That's fine. This is x is a function of y. That says g of y, but it could say function of y. That could also be function of y. And there's no problem with it being g of y or f of y. It's the same thing, okay? So they're saying here, I think we should do this one. Use the trapezoidal rule with 4 function values to find an approximation to the value of the integral between 7 and 1. Now be careful, guys. This is asking you, dy is an area with respect to the y-axis, not with respect to the x-axis. So you know what they're asking you? They're not asking you for the area under here. They're asking you for the other way. Do you see that? Because it's dy. We're going to be learning about this very soon anyway. It's integrating with respect to the y-axis. So when you integrate with respect to the x-axis, you get the area underneath the curve that touches the x-axis. When you integrate with respect to the y-axis, you turn it around and you're getting this area here that touches the y-axis. Do you get it? It's the area under the curve but bound or touching the y-axis. So the area I want here is not down here. The area I want, because I'm integrating with respect to y, we will be doing this when we do area integrations and you'll be more familiar with it. But it's across here. So I want that area. Between the values of y, because this tells me here, integrate with respect to y, I need the area bound with the y-axis. Between the values of y equals 7 and y equals 1. I want this area. So how am I going to do that area? Yeah, you can just use the same thing, but we're going this way. Because this is a function in y. Okay, so what are going to be the heights? I can do it this way, whereas the other one I couldn't because they gave me the function and I can work out the area under there and do it the other way. Look, I can do it either way. Actually, let's try it both ways.
So the x values the heights now.
Well, let's try, you know what I want to do? I think let's do it 2 ways. Oh, we've got to be careful, but you can't. You know, you can't do it under here. You know why? If you work out the area under here, you're going to get all of that. You can't form a rectangle. Look. You can't form a proper rectangle. You'll have to cut out this section as well. You've got to go this way. You okay with that? Now, why couldn't I do it here? Because this is all in terms of x. They've given me the function in terms of x. But here, we've actually got the function all in terms of y. So you turn it sideways and do it this way. So these are the values I've got. You can only go down with the values you've got. Do you see what we're doing? I want this space here. All right. How many sections are there?
3.
So, and what's the width of each trapezium? 2. Okay, let's go. So I'm going to have my page drawn sideways. So I'm going to do a little table. Look, my H is 2. Are we okay with that? But tell me what my function values are. I'm going to put them down here, g of y, my function values. What's the height here? Be careful. No, it's 9. And what's the height here? What's the height? 5. And what's the height here? Because how do you get to this point? You go 4, 3. What's the height? These are the heights. That's 9. Because that's 5. This is 4. And that's 2. So these are your function values because we're doing sideways. So the multiplier pattern is times 1 times 2 times 2 times 1. And I don't have to put those other values up here because I only ever use the function values. I'm not putting in the x values, right? But my height is 2 because the height of each trapezium is 2. Do you get it? 3 subintervals, 4 function values. So the area is approximately equal to h on 2. You know, we're doing h on 2 multiplier pattern, right? That's what we're doing. So the area is approximately equal to, h is 2 on 2. The 9 and the 2 are just added normally. And we do 2 times 5 plus 4. You okay with that? So it's 1 times 11 plus 2 times 9, 18. So what's it going to be? 29.
Wow.
29 units squared. Log to the base 10 on your calculator is just the ordinary button that says log. The button that says ln is log to the base e. So whenever you see log to the base 10, you just use the button that says log, L-O-G, not ln. So let's have a look. Just press log of 1. Log to the base 10 of 1 is just log of 1. What do you get? 0. That's right. Look, it is 0. Because when x is 1, the y value is 0. Log of 26. Look, it is 0. You can see it. Log of 26. What do you get? Actually, just write it as log of 26. I wouldn't be writing them in. You're going to get rounding errors. Log of 51, log of 76, and log of 101. Now, when you do your trapezoidal rule with the multiplier pattern, I'd be putting in the values, you know, that, plus 2 times in brackets, these added together, close bracket. What's your h in this case? What is h? Girls, what's the h? What's h? What's the distance between 25? Yeah. So h is 25 in that question. And how many values are you substituting? 5. There's 4 sub-intervals, 5 function values, and the function values in this case are the y values. Okay? So you do the area. You'll do the area under this curve. I'll just show you why you can't do it the other way. This way, look. For a start, this function is in terms of x, not in terms of y, number 1. If you want to integrate this way, the function's got to be in terms of y. That's why we could do it with the last question, because it was in terms of y. The function was in terms of y, and they wanted you to work out dy. They want you to go towards They want you to find the integral with respect to the y-axis. So they want you going that way. But this one, because this is in terms of x, this function, you can only find the area underneath. Okay? Whole area, what's this distance? It's the area of the rectangle. That's 101 times this height is log 101. That's what that height is. This point up here is 101 log 101. Do you get it? So it'll be, the area is going to be 101 times log 101. Got that? So what's the area? What did you get for the first part? 101 times log 101. What did you get for the area? Whatever you get, so you write it out. And then your trapezoidal rule does this area, and then the shaded area will be whatever you get. Spend a minute now and do it. The difference between your x values, if the data is given in a table, or it's just the difference between the x values here, which is 25. Or if you only had the 101 and the 1, it would be 101 minus 1 divided by 4 spaces, subintervals, which gives you 25 as well. Simpsons rule, you can do this one at home. They want 5 function values. 5 function values is how many subintervals? 4. So what would your values of x be if you were drawing up this table? 1, 2, 3, 4, 5 gives you 5 values. But to find your h, you know, it's b minus a over n. If you've got 5 function values, you've got 4 subintervals. In other words, it's 1. It goes up by 1. You know how to work out the y values, don't you? You substitute into the formula. You do that yourself at home. This one, do you know how to work out? You've got all your y values. How do you work out the h? How many spaces? Not how many values, how many spaces. I'm breaking up 420 into 6 spaces, not 7 spaces, 6 areas. So what's your h in this case? 70. You know what to do with the rest. Right, this is Simpsons rule. This question, this page, you can do those at home. This as well, you can do that at home. Y equals 2 to the power of x. You should know how to sketch that. Do up a table of values. Now let's look at question 4 and 5. Are we reading? The graph, so we're going to look at 4 and 5. Girls, 5 you should know how to do. Let's look at 5 first. How do you think you're going to do the shaded bit? How are you going to do the shaded bit? You'll do the whole rectangle minus the bit underneath, because when you find integrals or use trapezoidal rule and Simpsons rule, in this case Simpsons rule, you're finding the area underneath the curve. So you know how to find the area underneath here. What's h? Good. Now, so they'll ask you for the whole area. You have to do the area between the canal and the x and the y axes, all under here. They want the area of the cross section of the canal, which is shaded. That's the shaded bit. Excuse me, ladies. Then they're asking you for the volume of water in the canal. You know what a canal is? Yeah. If the canal is 2 kilometers long, what are you going to have to do? Volume, area of cross section. So that goes back. But look at the units all here. There. What are the units? Meters. What are you going to do with this kilometers? Yeah. So it's 2,000 meters long. I think you know what to do with this one. It's very similar to, yeah, when you're done with the area. So you're going to have to do, you're going to have to do rectangle, then the area underneath, subtract, and then find the volume. But we're not doing that. You're doing that one at home. Let's do question 4. You're doing that one now. So you're doing question 4 now. We're doing this one in class. Now, this is an application. The graph shows the velocity of a rocket in kilometers per second at time t seconds. Now, it tells you here that the area under the curve represents the distance traveled by the rocket. It's asking you to find the distance traveled by the rocket during the first 4 seconds by approximating the area. So they just want the area underneath this. Do you want to just practice one with Simpsons? And then we'll move on. Question for your H is 1, right? And then we've got our function values. So you're going to draw up a table. May as well draw this up in a table of T versus V. So you can go T and V. No, V's here and T's up there. No, the other way round. V and T. You've got 0, 1, 2, 3, and 4. What are your values for V? No. 5 is the first one, then 10. Be careful, what's the next one? 20 and right, and you can see your H from the table. What's H? Good. Area, remember the multiplier pattern. It's H on 3 and the multiplier pattern is 1, 4. Get it? 1, 4, 2, 4, 1. Okay, so 2, that's your pattern. So your area is approximately equal to a third, etc. You know what to do? 5 plus 12.5, 4 times the 10 plus 15, and 2 times 20. It's best to try not to use the calculator. I mean, you can for this middle section. 4 times 25, that's 140 plus this. 157.5, I think. Okay, and what do we get? Divide that by 3, it'll be 50. That's right. And that's units. The graph shows the distance traveled. It must be in kilometers. A rocket. So yeah, that is a lot of distance to cover in 4 seconds. 4 seconds. But it's a rocket, girls. It's a rocket. The velocity of a rocket in kilometers per second. The distance is kilometers. Okay. Wow.